Okay, ang topic natin ngayon is shaders. We can start in our default.vert. In our first line o yung ating version 330 core, the first line contains the version of GLS OpenGL shading or OpenGL shading language. And since we have OpenGL 3.3, we need to use GLSL 330 version or yung ating version 330 core. In the second line takes our input upon using the layout with location 0, where layout help OpenGL read the vertex data, it recursive. Sa ating void main, and for our main function, we simplify or assign GL position a vec4 with all our position plus an arbitrary for the fourth dimension. OpenGL recognize the keyword GL position, and it need to use it as the position for the vertex. Mag-proceed tayo sa ating vertex.frog. Vertex.frog o yung ating same lang din yung gagamitin version since ang ating OpenGL ay version 3.3. On the other hand, the fragment shaders especially says into the second line that it outputs a vec for color. For our main or ating void main, for the main function, we simplify, give it a color in a RGB. An RGB format to use for all the vertices. Sa pag-add naman ng kulay, we need to proceed in our main CPP. I mentioned that RGB values after each position into vertex array. If we need or if we want to change the color, we have to change also the coordinates of the colors, which is here in our 96 line o yung dun sa background, specify the color of the background. In adding color, we give each color its own color. So we wrote the RGB values after each position with the vertex array. Balik tayo sa ating main or sa ating default.vert. In our location or layout location in vec3, dito location 1 in our vec color, then we'll add a second layout with location I had takes at a vec3 name a color. Next, we need to output the color from the vertex shaders to the fragment shaders. Out vec3 color, and to do that, we need to output a vec3 name color. In the main function, make it equal to the color or a color imported from the vertices array. I will default.frog in a vec3 color, move the fragment shaders, we will out a vec3 in a same vec3 name color. And the final step for these shaders is to make the fragment or the frag color equal to the color, since that what we are putting. Fragment color equals to vec color or 1.0 yung sa ating void main. Sabi dito yung frag color equals to the vec4 color 1.0f o yung ating coordinate color. In our main CPP, ni-include natin yung shader class.h and also the vow o vao.h. Let's change the link VPO to the link attribute and add 4 variables. And now VAO do the same in the vow VAO CPP file and add the new variable as input to the GL vertex attrib pointer. And for our main CPP, now if you are press run, you should see, if you press the run, you should see that the triangle have a nice color of it. And now take a look in our default.vert. Now let's look at the second method of getting input and output within outside of the shaders. The second method makes use of uniform. The uniform are short of like universal variable that can be accessed by other shaders, and we can be even be accessed from within the main function of the program with the use of VAO. And let's